By this point, you should have gone through and balanced several redox reactions. And going through that process, you begin to see that each time you write a half reaction for the same material being reduced, whether it's iron 3 going to iron 2 or chromium 6 going to chromium 3, the half reaction is always written the same way, no matter what it's coupled to. Well, we take advantage of this in the form of measuring these half reactions in units of volts. In fact, you've actually seen tables, and you will see tables, of these half reactions before. You used to know them as the activity series, but what we've really done is we've actually started putting measured values or measured voltages that are associated with each one of these reactions. The cell potential, like I said, is measured in volts, and the volt is defined as a joule of energy divided by a coulomb of charge, or mole of electrons. The volt is named after Alessandro Volta, who was given credit for proving energy is stored in all things, whether living or dead. Volta was able to prove that energy is stored in non-living material by making a series of alternating copper and zinc coins and placing them on top of each other, separated by a piece of cloth, as seen in the cartoon in the lower right-hand corner of your screen. The cloth was soaked in an electrolytic solution to help improve the conductivity, and what he found was when he would touch either end of it, he would get a nice jolt of electricity. But what possessed Volta to make his voltaic pile here? Well, Volta was actually trying to disprove a theory going around by Luigi Galvani, who said that energy was only stored in living things and was called animal electric fluid. Animal electric fluid was kind of a popular idea in that thinking that people could potentially be recharged, or perhaps that death was called by people running out of energy. In fact, demonstrations were not uncommon in the day that they would take a fresh cadaver and roll it in for a show for the higher-ups in English society to watch a demonstration where a fresh cadaver could actually have its arms come up and move around, or its legs kick, or even if you touched it in the right spot in its chest, you could actually exhale its last breath or its dying breath. These, you can imagine, would be quite profound to witness, especially not having the background we now have about understanding how the body works. And one young woman who attended one of these demonstrations by the name of Mary Shelley witnessed such a demonstration and actually had quite a profound effect on her. She was about 16 at the time and was caught having an affair with a man closer to her age. At the time, she was married to a 40-year-old. And so when you get caught having an affair in those days, you go on holiday. So when Mary Shelley was caught, she went on holiday and spent time with her family. And one of the things they did while they were on holiday was they would tell scary ghost stories. And she was asked to come up with a scary ghost story to tell. Well, it took her quite some time. She couldn't figure one out right away, but she had a nightmare one night in which this cadaver was chasing her, giving birth to Frankenstein's monster, ultimately leading to the novel which she would write later on. So Frankenstein's monster is actually the product of an argument between Alessandro Volta and Galvani. Now, Volta's pile led to a huge leap forward in our ability to isolate elements that we suspected existed but couldn't actually find in nature. And working off of Volta's work, Humphrey Davy was actually able to isolate a number of elements which had long been suspected but could never actually be found in nature.